Hello everyone. In this lesson, we will study the principles and precautions of mechanical disassembly. Disassembly technology is a vital foundational skill in the field of assembly, commissioning, and maintenance of mechanical equipment. Mastering proper disassembly methods can not only improve maintenance efficiency, but also protect components and extend the service life of equipment. In modern industrial production, proper disassembly techniques are essential for equipment maintenance and repair. Statistics show that improper disassembly accounts for up to 30% of secondary equipment damage. For example, a factory suffered a direct loss of tens of thousands of yuan due to bearing failure caused by blind disassembly of a gearbox. This reminds us that standardized procedures are not restrictions, but a commitment to professional responsibility. By the end of this lesson, you will learn how to perform mechanical disassembly efficiently and safely, laying a solid foundation for future assembly and maintenance. In this lesson, we will cover the basic principles of mechanical disassembly, key precautions, and common disassembly methods. After completing this lesson, you should achieve the following objectives. 1. Understand and master the basic principles of mechanical disassembly. 2. Be familiar with precautions to avoid damaging components during disassembly. Develop a strong sense of responsibility to ensure accuracy and safety in the disassembly process. 3. Learn common disassembly methods and their applicable situations. First, let's understand the basic principles of mechanical disassembly. Disassembly should follow the following 7 fundamental principles. 1. Plan the disassembly sequence reasonably. When disassembling machinery, follow the order from whole to part, from outside to inside, from top to bottom, and from simple to complex. Specifically, remove external accessories first, then the main machine. Disassemble assemblies first, then subcomponents, and finally individual parts. This ensures an orderly disassembly process, avoiding damage to parts or increased repair difficulty due to disordered steps. The disassembly order is exactly the reverse of the assembly sequence. 2. Make thorough preparations before disassembly. Carefully study the equipment structure and working principle before disassembly. For example, with the THMDTK, one universal electromechanical training equipment, the operator should carefully read the manual to understand the structure, operation, performance, and assembly relations. For complex parts, refer to diagrams to clarify assembly relationships and fitting types, especially fastener positions and removal directions. In addition, the following preparations should be made. 1. Choose a suitable disassembly site and keep it clean. 2. Disconnect power to ensure safety. 3. Wipe down the equipment and drain any oil. 4. Protect electrical components and easily oxidized or corroded parts to prevent damage. 3. Reasonably determine the disassembly scope. Adjust the disassembly scope according to actual conditions. Avoid disassembling still functioning parts to reduce workload and preserve their fitting precision. If there are doubts about internal conditions, disassembly is necessary to ensure repair quality. Disassembling faulty equipment without inspection hinders fault diagnosis and later adjustments. Pre-disassembly tests or diagnostics can help identify hidden defects. 4. Use proper disassembly methods. Disassembly usually reverses the assembly order. Remove external parts, then break the machine into assemblies, subassemblies, and finally individual parts, grouped accordingly. Select appropriate tools based on component type and size. For non-removable joints, or those with precision concerns, exercise extra caution to avoid damaging the parts. Ensure operational safety during disassembly to avoid accidents. 5. Follow the principle of equivalence in disassembly and assembly. For shaft hole assemblies, the force used in disassembly should match that used in assembly. That is, The same level of force should be applied to prevent damage caused by excessive or insufficient force. If abnormalities are encountered during disassembly, the cause should be immediately investigated to prevent parts from being scratched, dented, or otherwise damaged. 6. Create favorable conditions for reassembly. The disassembly process should fully consider the requirements of subsequent reassembly. If technical documentation is incomplete, detailed records must be made during disassembly, including the disassembly sequence and assembly relationships, to ensure correct reassembly following the disassemble first, reassemble last principle. For precision or complex components, diagrams or markings should be made during disassembly to avoid errors during reassembly. 7. Clean and protect components properly. After disassembly, components should be thoroughly cleaned to remove oil, dust, and other contaminants, and then coated with anti-rust oil to protect the machine surfaces. Long, slender parts should be hung to prevent bending. Precision components should be stored separately to avoid damage, and small parts must be properly kept to prevent loss. Non-interchangeable parts should be grouped or marked to ensure correct reassembly. Next, let's look at precautions for mechanical disassembly. 1. Avoid disassemble blindly. When disassembling machinery, perform thorough analysis based on task requirements and minimize unnecessary disassembly. 2. Use standardized tools. Standardized tools should be used during disassembly to avoid damaging components. 3. Properly store disassembled parts. Prepare appropriate containers for storing parts during disassembly, and sort them by category or system. 4. Verify markings and fit relationships. During disassembly, check alignment marks carefully. Paired components should be grouped or nested together according to their original fit. 5. Make full preparations before disassembly. Before starting, prepare all necessary tools and note-taking materials. Adequate preparation ensures smooth operation and avoids interruptions or errors caused by missing tools or incomplete documentation. Next, let's learn about several commonly used disassembly methods. 1. Impact method. This method uses a hammer or other heavy object to strike or knock components, using the resulting impact force to disassemble them. It is suitable for tightly connected parts where high precision is not required. When using this method, care must be taken to control the striking force to avoid damaging the components. 2. Pulling method. This is a disassembly method that uses little or no impact force, suitable for high-precision parts that cannot be struck or where impact methods are inappropriate. For example, using a puller to remove a rolling bearing is a typical application of this method. Pulling is a safe way to disassemble components and minimizes damage, but appropriate tools and techniques must be chosen based on the part. 3. Pressing method. This method uses tools such as seat clamps, mechanical presses, hydraulic presses, or jacks to disassemble parts. It is suitable for simple interference fits. Uniform force must be applied to avoid local damage to components during pressing. 4. Thermal expansion method. This is used when components are large, have a significant interference fit, or cannot be removed using impact or pressing methods. It relies on the thermal expansion and contraction properties of materials. By heating the outer component, the interference fit is loosened due to the temperature difference. This method is ideal for high-precision, tightly fitted parts, but the temperature must be carefully controlled to avoid thermal damage. 5. Destructive method. In certain special cases, such as disassembling welded or riveted joints, seized shafts and sleeves, or when preserving the main part by sacrificing an auxiliary part, destructive disassembly methods may be used. This includes cutting, sawing, chiseling, drilling, or grinding. Note that this method causes irreversible damage to parts, so its necessity should be carefully evaluated and harm to the main components minimized. Through today's lesson, we have learned the basic principles, precautions, in common disassembly methods for mechanical disassembly. I hope that you will develop a sense of responsibility in practical operations. Strictly follow these principles and precautions. Select the appropriate disassembly methods, improve disassembly efficiency, and protect the components of the equipment. This knowledge will lay a solid foundation for your future studies and work. Finally, please review this lesson and complete the following exercises to reinforce and deepen your understanding. That's the end of today's lesson. See you in the next class.